So the next thing that we're going to cover after perimeter is area. So perimeter, we said, measured the distance around a space. Area tells us how much space is inside the perimeter. And area and perimeter are very different things. Okay? So area measures space inside, right? And two things with the same area can have very different perimeters. Area is measured in square units. So where before we saw inches, now we see square inches. Before we saw centimeters, now we see square centimeters, right? That can also be written as square centimeters, with the whole word square and the whole word centimeter, fine. And then square yards, etc. If you ever write an area without that little 2 in it, without the little square in it, it's actually not correct. Because what is 1 inch? In theory, if this were an inch, that's 1 inch, that blue thing, right? And this whole red box that I am highlighting, that is 1 square inch, right? So that is not the same thing. It's not describing the same thing at all as 1 inch. That's why we have to use the correct units to describe the correct thing. Okay, so let's imagine 2 different rectangles with the same area. Okay, I'm going to draw a yellow rectangle right now. I used 4 boxes, right? When they first teach kids area, they say count the boxes. 1, 2, 3, 4. Okay, the area is 4. Now let's take a look at what happens when I make it like this. This green box also contains 4 boxes, right? 1, 1, 2, 2, 3, 3, 4, 4. But what's the perimeter? Well, this one is 2 by 2. So it's 4 times 2 like we did yesterday. So the area of the green, this is just more like high school type notation, is 4 square centimeters. But the perimeter of the green is 8 centimeters. Let's compare that to the yellow one. It too has an area of 4, but look, it has one side that's 4 and another side that's 4, and one side that's 1 and another side that's 1. This is a nice review of yesterday. So all of a sudden, we have 2 different rectangles. The area of the yellow is 4 square centimeters with the exact same area, but the perimeters are different. And we'll see some problems later on that get to that a little bit. And many problems that you will see in life are going to get to that as well. Okay, so that's 10 centimeters, which is different than 10 square centimeters. So problems that require area are often like, I'm buying floor tiles, right? And the floor tiles are in square centimeters. Or I'm planting grass, right? How much grass? Or how big is the room, right? That's not a perimeter question, right? It's how much space is inside the room. So when you're reading word problems, you have to look for clues. Okay. So to find the area of any rectangle, you need to know its length and width. And starting basically tomorrow, we're going to replace those with better, more mathematically suitable words. But for now, we're going to let you call them length and width. Okay, because that's usually what people do for rectangles. So basically, the length and the width multiplied by each other give us the area, right? And you can see that if you count the squares, right? Before we had one like that. So let's look at this. This is 5 and a little bit squares and by 3 and a little bit squares. So if we count these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, we have about 15. 3 times 5 is 15. Now we've got all these little pieces to deal with. But basically that's what happens. If we were to make this into squares, we would have 6 squares going this way and 5.5 squares going that way. Okay, so let's do the calculations. And there's no more beautiful place to do the calculations for a rectangle than inside the rectangle. 6 times 5.5, don't forget that decimal place. So 6 times 5 is 30, right? Carry the 3. And then 6 times 5 is 30, so then we put 33. we put a decimal, and our final answer is 33 square centimeters. Okay, and if we drew the lines, we would find that we had those. Okay, and here we said this is a little more than 15, but we've got all these little pieces, right? So say we have 5.5, we're going to put 3.25 on the top because I know that's a more standard way to see it. This is not a pleasant or easy multiplication to do, but it's actually not so bad. 5 times 5 is 25, carry the 2, 5 times 2 is 10, plus 2 is 12, carry the 1, so now we're at 16, we need a 0 here, and because that 5 is the same as those, it's actually the exact same digits, just moved over 1, and then we're going to have 3 decimal places in our answer, 1, 2, 3, okay, and our answer is going to be 17.875, or that's actually 17 and 7/8 for those of you who are up on things. And that's going to be also measured in square centimeters. So again, we had 15 here, and then we had another quarter by a half, quarter by a half, quarter by a half, and all these little pieces together added up to 2 and 7/8 square centimeters. Okay, so what about composite figures? You're going to see a lot of those. So this one's a little bit midgetic because there are so many pieces of it. But basically, in theory, as long as you can divide a big figure into other rectangles, it's really not hard, right? So this rectangle is 3 by 4. 3 times 4 equals 12. Okay? This rectangle that I've outlined in red is 4 times 4. And that's 16, right? We're going to have all these pieces, we're going to add them up. So then you can tell me that this rectangle is 2. Let's imagine that they're centimeters. If it ever doesn't tell you, by the way, what they are, just call it units, like square units. And this is actually 1, 2, 3, right? A 2 and then a 1. So that's 3 square centimeters. So the total is 12 plus 16 plus 2 plus 3. And we add those up, we get 3, carry the 1, and we get 33 square centimeters. Okay, so we're going to do a much more normal one here, although the numbers aren't pleasant. What we just do is we just draw like an imaginary invisible line, and we did this with perimeter yesterday, and you're going to see that a bunch that I bring back the same ones. Okay, so the bottom part of this rectangle is actually super easy. The bottom part of the rectangle is 1 times 4. Okay, that's just a rectangle. So that is 1 times 4, which is 4 centimeters squared. Now the top part, the hard part is always figuring out what the pieces are and what's the best way to put the pieces together. So the top part has more annoying numbers, but we can do this. We can multiply. Its length is 3.5 centimeters and its width is 6 6/10 of a centimeter. Now, remember that it actually doesn't really make a difference what's length and width. If you're going to use those words, usually length is longer than width, but it doesn't make such a difference because the bottom line is very soon we won't be using those words anyways. Okay, so the length is 3.5 centimeters, and the width is 6/10 of a centimeter. And this is where I would actually do the math, probably with fractions, because 3.5 is 7/2, and 6/10 is 3/5. Then all of a sudden, we just have 21/10, which is 2.1 square centimeters. And again, you've got a final step where you add the pieces together. You do 4 plus 2.1 square centimeters is 6.1, 6 and 1/10 of a square centimeter. Okay. Now, a square, by the way, again, because a square is a rectangle, a square behaves like a rectangle. And we can say that's 4. Actually, that's a bad choice. Let's pick a different number. Let's say that that's 5 centimeters. Okay. All you need to know for a square is the side length. Now, it happens to be that 5 is functioning there both as the length and the width. So we're going to multiply 5 for the length times 5 for the width. And we actually call multiplying a number by itself or writing it as a factor twice squaring, right? That is what we have done with this case, right? So whether you consider a square something different or by itself, what you're essentially doing is still multiplying the length by the width. Okay. Now we can work backwards again, and so again, instead of multiplying, we will divide to work backwards. So if I have a rectangle and I know that the area inside is 36 square centimeters, and I know that this number is 3 centimeters, well then this number times this number has to equal 36. So to find my length, all I have to do is my area divided by 3 to undo the multiplication, and I get 12 square centimeters. And if you're not super in love with those, don't worry, we'll get lots of practice. Now, some of you might already be stopping here. Word problems are helpful. They put this in context, and these are real problems. Like, you could do this. Okay, so Susan's helping her father. Pause and read the question, and then highlight all the important words. Okay, so the first thing we're going to do is we're going to draw a picture. It's a rectangle, 14 times 10, okay? Now, carpeting costs $175 per square foot. The fact that that's square units is a clue to us that this is an area problem. So what's 14 times 10, length times width? That's 140 square feet, right? So to find the correct answer, if the carpeting costs $175 per square foot, we need to multiply the number of square feet we need times the price per square foot, and we will get our correct answer. Again, this is, I think, a case where we may actually be better off functioning in fractions. 140 has a nice 0 at the end, and 175 is 7/4. So if we do 140 times 7 over 4, and that becomes 70 over 2, and that becomes 35 over 1, then all I have to do is 35 times 7, and that's 210 plus 35, and that is $245. My units here are dollars because I'm paying for the carpet with money. And the last little bit is the baseboard, okay? It needs to be installed along the base of the walls, and it's $235 per foot. Fascinating. What that tells us is that this is perimeter, because it's not square foot, it's foot, right? So we need the perimeter, but there is one 6-foot wide entry that doesn't need baseboard, a gap, right? So we're going to have length is 14, and we need 2 lengths. With this 10, and we need 2 lengths. And then we take away the 6 that we don't need. We got 28, 48, 42 feet. And now we multiply that times 2.35. Okay, and because this video is getting long, I took the liberty of pausing. And in fact, when we do the multiplication, we get $98.70 is what 42 feet of baseboard is going to cost, which makes sense because 42 times 2 is 84. So it's in the same ballpark. And that is how we, A, find area, B, find side length from area, and D, use area in a problem. Have a great day.